Hi guys, so today we are going to look at solving both log and exponential equations because some of these exponential equations are going to require logs to be able to solve. So we're going to start with log equations. These first two are going to be kind of our more basic ones, and then we'll look at probably the two most common types of log equations that you'll see. So your goal here is, if it's possible, get the log by itself. In this case, the log already is by itself. Once the log is by itself, then let's rewrite it in exponential form. So to write this in exponential form, 2 is the base, 2 to the third is equal to 2x minus 4. Then from here, all we have to do is solve a pretty basic equation. 2 to the third is 8, and divide by 2, and I get my answer. All right, let's do another one. Again, the log is already by itself, so let's write it in exponential form. X to the negative second is 1 over 81. So what number raised to the negative second power would give us 81? Well, that number is 9, because 9 squared is 81, and the negative would move it to the bottom. Now, sometimes that log is not already by itself, so we're going to have to do a little bit of work ahead of time. So on this first one, we have to get the log by itself before we rewrite it. So in this case, the log right there is the natural log of x minus 1. So to get that by itself, I have to get rid of the minus 7 and the 2 out in front. So let's start by adding 7 and then divide by 2. Then we can rewrite it in exponential form. So remember, ln has a base of e. So e to the fifth is equal to x minus 1. So my final answer here would be e to the fifth plus 1. Now, if you don't have a calculator, this is the answer that we want to have. And even if we have a calculator, this is actually our best answer because this is our exact answer. Now, at this point, if you have a calculator, go ahead and plug it in and actually see what that decimal is. But this is our best answer right here. All right, now, sometimes it's going to take a little bit more work to get these logs by itself. So one thing we may have to do a lot is use those properties that we did last class to condense some logs together. So look over here at the right side of this equation. I can condense those using the properties that I did last class. The 2 out in front can become the exponent on the 4. Then, using those same properties, if you're subtracting logs, then you can divide the arguments. So this would be 16 divided by 2 for the argument, which is 8. Now, at this point, this is a little bit of a different equation. We have a log of base 3 equal to a log of base 3. Well, the only way these two things can be the same is if the arguments are the same. So what we do at this point is just take the arguments and set them equal to each other. And we get our answer. So the other type of log equation, well, I guess we'll get to that one in a second. Let me go ahead and do 5 first. Again, on this one, using your log properties, let's condense the 2 that are on this side together first. So because those logs are subtracted, we can divide the arguments. So 10 divided by 6 is 5/3. Since we have a log equal to a log, we can set the arguments equal to each other. So 5/3 is equal to 5x. So to get x by itself, we're going to divide by 5, but that can be a little tricky with a fraction. So remember, dividing by 5 is the same thing as multiplying by 1/5. So I end up with 5 over 15, which is 1/3. All right, so again, this next one's going to look a little similar, but be a little bit more like our first ones. We're still going to use our log properties to condense these two logs together. So using those log properties, 2 logs that are added, I can multiply the arguments. So x plus 2 times x minus 1. So we can go ahead and FOIL that out. So that would be x squared plus 2x minus 2. And I'll go ahead and simplify it. So that'll be x squared plus x minus 2. Now at this point, we don't have a log equal to a log. We have a log equal to a number. So this is really similar to the first couple we did. So instead of setting those arguments equal, we're going to write this in exponential form. So the base for log, if there's no base written, is 10. So in exponential form, 10 to the first equals x squared plus x minus 2. Now this one's quadratic, okay? So in order to solve this quadratic, let's set it equal to 0. And this one factors, because we can figure out what multiplies to negative 12 and adds to 1. Those numbers are 4 and negative 3. Because there's no number out in front there, it's pretty easy. That's all we need to do is find those numbers. Now to find our answers, remember we set each factor equal to 0. So I get 2 possible answers, negative 4 and 3. Now this one has one more extra part to it. What we need to consider here is that you cannot have a negative argument of a log. So if I took negative 4 and I plugged that back in for x to my original equation, I would get the log of negative 2 plus the log of negative 5. I can't have negative arguments for logs. So what that means is that negative 4 is not actually a solution. Negative 4 is referred to as what's called an extraneous solution, which means it doesn't actually work. So in this case, there really only is one answer, and that one answer is x equals 3. All right, so now we're going to move on and look at exponential equations. So really there's kind of two main types of exponential equations we're going to look at. This first one is really similar to what we did on the first day when we were solving some of those log questions with the fraction exponents. What we want to do is we want to rewrite these in terms of the same base. So what I mean by that is we want to make it to where, so this is a base of 3, I want this to also be a base of 3. So I need to think how I can rewrite it. Now these are really missed a lot because people think, well, I'm going to go ahead and square root this so it's the same. The problem is you can't just square root one side of an equation because that changes it. Whatever you do to one side, you'd have to do the other, and then that's going to make a big mess. So what I have to do is rewrite this. So the square root of 3, I can rewrite. That's the same thing as 3 to the 1/2 power. So all I did right now is just rewrite that. Well, now these bases are the same. Since it's 1/2 to the x plus 1, I can multiply those together. So that's 1/2 x plus 1/2. And now, since my bases are the same, the only thing I have to solve are the exponents. So then I'm going to subtract 1/2 x from both sides. I'm going to add 1 to both sides. And I'm going to multiply by 2. And I get my answer. All right, 6 is a little trickier, but again, we want to write both sides in terms of the same base. Both of these can be rewritten as 3 to the something power. 1/9 is the same thing as 3 to the negative second. 27 is the same thing as 3 to the third. Those exponents get multiplied together. So this is 3 to the negative 4x. This is 3 to the 3x plus 3. Once those bases are the same, we just set the exponents equal and solve for x. So if you're able to write these in terms of the same base, that's probably the best way to do it because you're going to get a nice, exact, easy integer answer. Or rational answer, I should say. Sometimes, though, that's not possible. Okay, if you look at 7, all right, there's no way, well, the first 7, sorry about that. There's no way to write 5 and 6 in terms of the same base. So if that's not possible, what we're going to do is we're going to rewrite this in log form. So remember, the base of the exponent is the base of the log. So this would be log base 5 of 6 equals x minus 1. So that's rewriting it in log form. Now at this point, to get x by itself, all we have to do is add 1. But remember, you're taking the log of 6. 6 is the argument. What that means is I can't just add 1 to the 6. All right, the 6 is the argument, the 1 is not. I can't actually add the 6 and the 1 together. I have to leave it there. Same idea on 7. Okay, let's rewrite this as a log. So log base e of 5 equals 2x. And if you remember, log base e is the same thing as ln. So that's the best way to write this. Then your last step to get x by itself is divide by 2. And remember, we're not just dividing the 5 by 2. You're dividing the entire natural log of 5 by 2. So your exact best answer is the natural log of 5 divided by 2. Now, at this point, if you have a calculator, you can go ahead and plug these in and get the actual decimal. But I will tell you that actually just finding the exact answer like this is going to be a little bit more important. All right, so these ones are very similar, but we have to do a little bit of work first. So in order to write this as a log, I need to get that exponent base by itself. So very similar to what we did on the other ones. To get that by itself, I need to start by adding 8 to both sides and then dividing by 2. Now that that exponent base is by itself, now I can write this in the form of a log. So the base of the exponent is the base of the log. So now it's written in log form. So now all I need to do is get x by itself. So I'll take log base 5 of 7. I'm going to add 1. And remember, I'm not adding the 1 to the 7. The 7 is part of the log. It's part of the argument. We can't add the 1 to it. Then I'm going to divide everything by 2. And that whole thing divided by 2 is my best exact answer. All right, last one. If you feel comfortable, pause the video. Try this one on your own. All right, so again, I want to get the exponent by itself. So I want to get this e by itself. So in order to do that, I'm going to start by adding 2. Then I want to divide by 2. Now I can rewrite this as a log. So log base e of 3 equals x over 3. Or again, remember, log base e is the same thing as ln. Now your last step to get x by itself is to multiply both sides by 3. So 3 times the natural log of 3 is your final answer. All right, so that's all we have for solving log and exponential equations. Again, we'll have a lot more practice in these in class, but this is the last new thing before your quiz.